Okay, so our first code build is a very cute pattern that you will find, but is evil, that you will find most of the time in your code. And the pattern goes like this. You have a variable, probably inside a class, which holds a state. The state is if something has been set or not. And the way you use it, you initialize it to your preferred state. In this case, this has not been set yet. And in one of your functions, you just want to check, oh, is this variable has not been set yet? And you do this conditional if. And if it's not, you just do something and then you set it to true, so you will never do this again, right? It's very, very common that you will find it pretty much everywhere in your code. Well, in a few places in your code, that's it. And what I like about this way of doing this code pattern is that you split the logic into different places, but it's still part of the same logical process. Like this variable here, it just holds. It's a very atomic variable, right? So you don't want to split logic into multiple places, especially if you are going to repeat the logic all over your place, because once you have another bool which has another type of check, you're always gonna repeat this these few lines of code. And usually one of the rules is if you have that the same, pretty much similar lines of code that are repeating throughout your code, and they have the same logic and the same pattern, you just need to do something and not to have them repeating all over the places, because the big problem with that is that once you need to change something, you just need to check to search all of the occurrences of what you want to change and then manually change all of them. So a better way to deal with this problem, because it's so quite common, is just to use what we call a functor to handle this logic. And I show you basically here. The functor is what we call, it's just an object, it's just a class that has one main function, which is operator function call, which is this open and close parentheses. And in this case, I'm basically moved all this logic of check and set into this function here. So this becomes just a function call. And if you see here, it's basically the same thing. It will return a value, right? This is the template class. So in this case, it would be a template bool. So it will return a bool. So you can do this conditional if here of the whatever value is set, this class 2, and while assigning a new value, okay? So it will check the old value, but assigning a new value. And this is exactly what is gonna, what we will be doing here. So it's gonna check if it's false, but it's gonna set it to true. And all this will come down to is, this is exactly the same class, but instead of this naked bool, right, we have a bool which is wrapped into this test and set factory call. Name is not great, but you can name it whatever you want, and has been set, right? So it's exactly the same, but it's wrapped around. And if you see, the beauty of this is like this function here, it doesn't have any split logic now. It has just one function call. So this is check. If it's not been set, then set it to true. So you pass it what you wanted to set it to, and you check what you want to check. So actually, it's not been set, then set it to true, right? So this is a very elegant way to make all this split logic into a single function. So the gain of this method is that whenever you need to change the logic of your check and test, you can just do it into your one function here without looking around the code forever to see where you can actually spot this pattern. And it's not really easy to spot either, because this is not really easy to search, because you will have infinite bools in your code, and you will have infinite places where you set things to true or false, and when you do ifs. So this is going to be very, if you forget to do this, you're already in trouble. It's just and it's very error prone here. You cannot go wrong. It just does. Everything in here is nice and atomic and encapsulated. Last a few words. Of course, this has got an overhead, because this small template function is just a class, and you call a function instead of like reading from a variable. So don't use this if you need to do checks like that into high performance code. Just use it only if it's like just some architectural logical code that doesn't get run a million times every second. So it's like very low overhead. You can have like this nice pattern. And that's it basically. And I catch you later for the next one.